Hello, everyone. Welcome to another GEP's live session. My name is Priyanka, Senior Marketing Manager at GEP, overlooking the live program along with the Europe region's GTM strategies and ops. Today, we will have a very interesting discussion with an amazing panel about if EV batteries will disrupt automotive supply chain, just like chips did, or not. Just to put things in perspective, did you know which US state has the highest number of EV charging stations? While you ponder on that question, a quick introduction to the esteemed speakers, Pranav Padgaonkar and Bryan. Pranav is a vice president at GEP based out of Atlanta. He has around about 18 years of experience focused on supply chain and procurement. He leads large consulting engagements focusing on improving business outcomes and has worked with GEP's key clients across a wide spectrum of manufacturing industries in all major geographies. He also provides thought leadership on supply chain, focusing on a variety of subjects like process excellence, manufacturing, smart factory, and Internet of Things. He also is very passionate about automotive industry and has an electric vehicle because he's an enthusiast. Bryan is a senior director at GEP and has extensive experience leading manufacturing and automotive clients through global initiatives such as digital transformation and rapid sourcing. He has a diverse background in a variety of industries uh, and is managing a wide range of categories such as MRO, capital equipment, and services, facility services, temp labor, IT, professional services, logistics, and much more. Bryan is also a leader of GEP's automotive and industry manufacturing verticals, although I'm not sure if he also owns an electric vehicle like Pranav. But yeah, welcome both, and the floor is all yours.
Thank you, Priyanka. Appreciate the introduction. So, as we're getting into this, let's start with setting the groundwork for what happened with the chip shortage. There were many causes. Clearly, the COVID pandemic was part of it. But if we look at the underlying structural issues, they're really top four items that caused the chip shortage for the automotive industry as well as many other industries during the last few years. First of all, the total overall capacity in the fabs for production of chips was short of what the world demand was. Secondly, the auto industry was not a top customer for many of these chip manufacturers. The chips that the auto industry typically requires are lower value, lower margin, more antiquated design chips. So it would be analogous. The auto industry asking for more capacity would be analogous to someone asking Sony to ramp up their capacity for making CRTs today. So they were not the first in line for the priority of the chip manufacturers. Third, there were other sources of demand growing very rapidly, obviously much more rapidly than the auto industry. Just to give you an example, in 2000, there were about 17 million cars and light trucks sold in the US. In 2019, there were about 17 million cars and light trucks sold in the US. But in 2000, there were no smartphones. In 2019, there were 150 million smartphones sold. So that and many other emerging technologies really pulled capacity away from the auto industry and into these other spaces for these other applications. Finally, there was a bottleneck that was probably largely overlooked, which was tier two suppliers. While the OEMs and major auto manufacturers buy assemblies from multiple suppliers such as Bosch, Denson, Visteon, etc., and may have felt that they had some redundancy in those supply chains. Those suppliers themselves are buying. We're often buying chips from a single manufacturer. So there was a single source issue that was underlying the supply base that the auto manufacturers were looking at themselves and were focused on in their supply chain risk assessments. So there are, we think, some very good analogs to what we all need to be considering in the EV battery supply chain and battery market. And Pranav, can you explain some of those perspectives that we pulled together?
Sure, Brian. Yeah, I think it is very much in parallel. So if you talk about the overall capacity, that is the big question right now, whether the overall battery capacity in the world or in the US is going to be sufficient for all the ramp up of EVs that are going to get sold. We will discuss that further in this discussion. The second part, where the auto industry demands low-end chips, there we are good on batteries, because the auto industry in fact demands the highest end, most energy dense, most performance heavy, long life batteries. So there, that is not going to be a constraint. That's a stark difference compared to the chip scenario that Brian described. But the other restrictions or hurdles still remain. So there are other sources of high demand. In particular, I think commercial vehicles and then grid storage are two demands which are also ramping up along with passenger vehicles. So those are likely to get in the way. And then there are others. We'll discuss more. And lastly, on the tier 2 suppliers, for chips, it ended up being the fab suppliers. But in the case of batteries, it is going to be the miners, the rare earth metals, the lithium, the cobalt, nickel, all those are the tier 2 suppliers. And there is definitely a supply constraint on that end as well, which we will get into. But even before there is a supply constraint, there may be a price volatility constraint, which we will discuss in the rest of this discussion. So let's get into it. And just to guardrail the discussion, when we look at this, the problem is really global, but the Inflation Reduction Act, the IRA, has actually created a scenario where the US market is slightly insulated from the overall world market in this situation. So what are the restrictions that the IRA has imposed? I think the main restrictions are on the critical minerals of value and the battery components themselves. So the critical minerals have to be 80% sourced from FTA countries by 2027. The battery components, 100% manufacturing has to happen in the US by 2029. What does this mean? It means that as long as automakers are looking to cash in on these incentives, which are fairly huge, $7,500, they need to design their supply chains to meet these as they build their plans. Now, that also means for us that we can look at the US market in isolation when we are looking at the estimation of demand and supply to some extent. Now, the curious part about the IRA right now is that it does not impose these restrictions on commercial vehicles. Now, you can imagine that is going to cause some additional supply chain constraints, because when the same companies are making cars but are also making commercial delivery vans or semis, they almost have two different incentives on the two sides of the supply chain. But we will get into that. Now, it does say that these constituents have to come from the FTA countries. There is a list of 20 countries, which does include Chile and Australia, the large lithium miners of the world. So it is not entirely domestic, and as far as minerals are concerned, but it is a fairly restrictive source that has to be used. So when we get into like how does this really impact the supply chain, let's first look at what are the components of the EV or the battery supply chain in particular. So there are 4 steps that we look at. The first one is just the mining itself that we spoke about. Here there are a lot of different battery chemistries, and the science is not yet settled. There are new chemistries evolving all the time. There are manufacturers moving from one chemistry to the other. Like Tesla plays between NMC and NCA, but have also started using LFP now. GM has moved from NMC to NCA, and so on. Now, what are these acronyms? Those are the primary minerals that are used in the battery chemistry. Now, if you look at the first two battery chemistries, NMC and NCA, they both require nickel, but the last one, LFP, does not. So suppose a manufacturer says, okay, nickel is high price mineral, let's go with LFP. That could cause problems down the supply chain in the final aspect of integration. Why? Because, well, LFP doesn't have the same energy density as the other two. It doesn't have the same performance as the other two. So if they are trying to build a compact car or a sports car, they might face issues all the way down. So all of these steps are interrelated, intertwined, and there is literally numerous permutations that have to be dealt with. Now, the next one there, cell production, same thing, right? Whether currently the competition seems to be between cylindrical cells, which are metal encased like your AA battery, and pouch cells, which are more like your mobile phone battery encased in plastic. Very different products. So the very different manufacturing process for those two. If someone has to switch from one to the other, it is probably going to cost a few $billion if they've already set up a couple of battery plants. So these are not small changes. These are huge changes which have to be made very carefully and take a lot of investment dollars to switch over. The next part is the module assembly, where all these cells are combined into a module, which gets to the desired voltage, has the battery management system, but in the future could also have very structural elements, could be part of the car's chassis and structure. That could create another set of complexities. And lastly, there is the vehicle integration. Depending on the car and the range and the variant that is required, a number of these modules will be placed in the car, and then they have to be cooled and they have to be placed right, and so on. So all these permutations, I mean, the key message really is so many permutations, so many complexities to be dealt with, and all these have to be frozen before automakers start making billions in investments to build a plant which will make these batteries. So that, with all these constraints, then how are we going to go through or navigate through all this, right? So we can look at the demand and supply equation, the crux of what we were trying to discuss here, with this background. So let's look at the demand first, right? So how many batteries are going to be needed? What is the battery capacity? This is typically measured in gigawatt hours. So there is two parts to this question. The first is literally how many gigawatt hours, what is the amount of batteries that EVs will need? And the second question is by when, what is the timing? So as far as how much is concerned, like one benchmark that is very commonly used is 50% of car sales being EVs. Now in the US, as Bryan mentioned earlier, 7 million cars typically are sold somewhere in that region. Half of that would be 8.5 million. And the battery pack size across BEVs and plug-in hybrid vehicles is approaching 70 kilowatt hour as we speak. So if we do the math on that, we would need almost 600 gigawatt hours of battery capacity to power half of the car market being EVs. The question is, by when will we need this capacity? On that, the forecasts are drastically different from each other. But if we look at the current set of forecasts that are there in the US, a growing majority of them tend to say that the 50% milestone is going to come around 2030. So as you see, the Bloomberg NEF survey is saying after the IRA was introduced, we are now looking at 50% by 2030. And there are many other forecasts like this. But on the other hand, if we look at the real world example, China in this case is a couple of years ahead of the US in terms of that transition. So US is today at 6% EVs as a percentage of total sales. China just a couple of years back, 2020, was at 5%. So somewhere in the vicinity. But today, as of 2022, they are already likely to cross 21, 22%. And they are now on an exponential curve. It is no longer looking linear. Even if we take a linear projection, they are likely to hit 50% from 5% within 5 years. That's a very, very drastic change. If we follow that curve, the US could actually get there in 2026 or 27. That's just a few years out. battery plants that are announced in the coming months will go live only in 2026. So that is a fairly urgent scenario. So in conclusion, right, what it will remain uncertain, and it will have to be adapted and adjusted every quarter. But what we are looking at is somewhere between 2026 and say 2030 or a couple of years out, EV sales are going to hit 50% of total car sales. And at that point, 600 gigawatt hours of capacity has to be ready live in production. So then let's look at the supply side of the equation. Are we getting 600 gigawatt hours? The answer is yes. We are getting 600 gigawatt hours. If we look at all the battery plants that have been announced in the US over the last couple of years, before and after the IRA has been launched, we would expect a few more such announcements. But as it stands today, the total capacity from all these announcements adds up to 741 gigawatt hours. Typically, between announcements and actual production, there is a 20%, 25% drop. So if we apply that thumb rule, the total capacity that will come online by 2026 is going to be 592 gigawatt hours, fairly close to the 595 that we needed. Let me take an aside here quickly to look at a couple of the other numbers that are on the slide. If you look at the direct jobs that this is creating, 55,000 jobs directly created just for battery manufacturing. This does not even take into account vehicle assembly. $60 billion or close to that investment going in domestically in the US just for battery manufacturing. This is huge. This is probably the biggest manufacturing mobilization in recent US history. So we have to look at it in that perspective. This is unprecedented. Even the announcements that have already happened. But then with all these announcements, are we saying, 600 gigawatt hour is what was needed, 600 is what we are getting, problem solved, right? Well, we don't think that's quite as easy as that sounds. So we have to look into, what is really the other constraints that we are coming across, right? So when we look at all this plant capacity, the assumptions we are making, if we equate the 600 to each other, we are assuming that the battery chemistry and the structure is not going to evolve significantly, right? We are also assuming that the price of all the materials is going to stay stable so that the demand supply equations remain stable. And lastly, we are assuming that all the battery plants being thought of today are going to make batteries only for passenger cars. Now, all these are shaky, but particularly that last one, that all the demand is, all this supply is going to be consumed just by cars. That is pretty shaky. What do you think, Bryan?
Yeah, Pranav, great overview on a lot of points there. I think that it's such a fascinating market and it is changing so rapidly. Let's talk about what are some of these other risk factors. First of all, regarding capacity needed for cars versus capacity needed for other applications. So what percentage of batteries, would everyone think of these high-end EV appropriate batteries would go to passenger cars? So an example that we can take is with Tesla. Tesla has estimated that by 2030, their ratio of batteries going into passenger vehicles versus other applications will be 7 to 13. So meaning that for every 7 gigawatt hours of capacity needed for passenger cars, 13 gigawatt hours will be needed for other applications. So what are these other applications? So first of all, there's heavy commercial vehicles, right? And this is being accelerated by the IRA. So there are incentives for municipalities and other governments to switch to electrical. So that has already started creating actions, such as California working to start having their school buses switch to electric. If we look at the commercial side, there are semis already from Volvo and Freightliner in the market that are electrical, and Tesla just announced the launch of their all-electric semi. Another area that is seeing rapid expansion, we think will continue to grow quickly, is on light commercial, the last mile delivery. Obviously, that is a huge industry with all of the online shopping we do today in the U.S. And there are already, vehicles in the market that are being utilized, and that will continue to grow. Then there's another aspect, right? Grid and home storage. There's a couple of factors there. One, as we move to more green energy sources, particularly electrical and solar, there is more variability in the supply of electricity. And also, as we move to more electric vehicles, there will be a need for charging at night. And as it happens, the supply is typically greatest from those wind and electrical sources during the day, whereas there's going to be a need for supply and a large demand at night. And this suggests that grid storage will need to continue to expand, and probably rapidly. Finally, and by the way, these are all existing today. These are, they are expanding and growing, but these aren't new technologies. And finally, one of the technologies that's been around for a while but continues to grow are the industrial equipment, such as the robots, the fork trucks, etc. You think about a lot of the material moving equipment utilized in warehouses, also impacted by this continued expansion of online shopping and the rapid growth of warehouse capacity in the US. So with all of this in mind, and looking at that ratio from Tesla, that would suggest we don't need, it's not 600 gigawatt hours we need, but over 1,000 gigawatt hours of new capacity. So with all of that, that's not even the whole picture of what's creating more demand yet. There are new applications coming online. For example, there's a company, Eviation, which is making electrical aircraft. They already have over 300 orders on the books. Some of the first electric-powered ocean freighters are already on the water. In addition to that, there's large mining equipment. Caterpillar just demoed this new all-electric truck for mining, a huge piece of equipment. And John Deere is 6 years into their journey of electrifying farm equipment. And there's even more. If you look down the right side of the visual here, lawn equipment, military equipment, drones, etc. So there are many uses of batteries beyond just the passenger vehicles that was in the equation that Pranav was outlining earlier in the supply scenario he was outlining with the 600 gigawatt hours. So where does that take us? I want to get to the fourth and last kind of comparison between the chip market and the EV battery market when we look at the risks. So that last component is around tier 2 supply. I think as Pranav mentioned, in the battery world, the tier 2 supply, not the fabs, it's really the mines. And so we don't think that the world, when we look at the projections, is probably going to run out of lithium, but we do think that there are still a lot of risks. And it's not just lithium. Nickel's a major component. There's graphite, there's cobalt, there's the rare earths. And currently all of these have supply constraints. The rare earths in particular have supply constraints, for domestic production. And as mentioned, domestic production will be important to satisfy the requirements of the Inflation Reduction Act. And battery chemistries also keep evolving, right? So even what inputs and what materials are going to be needed 5-10 years from now may be different. But we think there are two primary issues really to focus on, right? One is securing materials within the U.S. for those incentives on passenger cars and satisfy the IRA, and the other is securing materials at a low enough cost. Now, while most of the major auto manufacturers have stated that they do have supply secured for the next couple of years, the cost for these materials often rise drastically when the supply becomes tight and well before there's an actual shortage. And that's what we've been seeing in the lithium and nickel prices, which have both doubled in 1 and 3 years respectively, as you can see from the graph. So there's a fair amount to be concerned about on the inputs of the materials to the batteries as well. Again, both on supply and very critically on cost, because all of the auto manufacturers have based their plans on cheap batteries and batteries getting cheaper over time. If it goes in the opposite direction, that is going to have a material impact on their plans in many ways, and will require a rethink in many of these aspects. So we've covered a lot of challenges and a lot of negatives here, but it's not all on the downside. There are some aspects when we look at the supply chain that I'd say maybe give us some hope. Pranav, do you want to take us into that side?
Yeah, sure, Brian, and thanks for scaring us all by saying that demand is going to so far outstrip supply. Yes, that is a matter of concern, but there are a few factors which could also reduce demand as we go, because between now and 2030, technology is very rapidly evolving. Right. First, if we look at the battery demand itself, there is a lot of alternate energy storage technology that is also coming up, particularly for non-automotive or grid storage kind of applications, which are intraday. The requirement is very different. Store something for discharge at the end of the same day, right? So the discharge rate of the battery and the other characteristics required are very different. So some of these areas could be met by by non-battery applications, or by at least non-automotive grade applications. So for example, in Switzerland, there is a big hydro storage project going up now where water is just pumped up and pumped down at night, storing it as potential energy, or flywheels and capacitors and so on. There are technologies which can come in here and put a dent in the grid storage application, which is one of the largest. Then there is alternative propulsion. Hydrogen fuel cells and hydrogen-based internal combustion engines have been doing the rounds. They haven't really taken off, but they could still find niches in commercial space or in other such small pockets. Still could put a dent in the total battery demand. Lastly, alternate transportation itself, if ride sharing and or robotaxis and all of that picks up, that could have an impact on the total amount of automobiles sold itself in a downward direction, where personal ownership of a vehicle is no longer as critical. That could have downward pressure on the battery demand. Similarly, when it comes to mineral demand, I think alternate battery chemistries are coming up, announcements in in the media every couple of weeks. I think the biggest such announcement recently was Cattle, the world's largest battery manufacturer, stating that they are going to launch their sodium-ion batteries within next year. Now, what does this do to all the lithium mines which have primed and said, okay, we are going to send all our production to EVs? Suddenly, Cattle says we no longer need lithium. Granted, their current sodium-ion technology is likely to have limitations on where it can be used, probably only small cars, low-performance cars, but that is going to evolve as well. And they are the world's largest battery manufacturer. So, that could put a significant dent in the demand for lithium and some of the other similar chemicals. Other than that, there are a series of startups and large OEMs, everyone from Toyota, going after solid-state batteries. Those, again, have a different chemistry typically. There are startups like StoreDot going after very fast charging batteries, again, a different chemistry. So all of those could have a downward impact. on the demand for the minerals itself. So there are all these factors which could cause downward demand, right? But then what we've seen so far overall, right? If I just recap quickly, there are automakers have made plans to cater to the car demand that is immediately visible or looking like it will occur by 2026, or even what possibly till 2030. However, there are similar to chips, there are concerns about other sources of demand absorbing some of that supply and creating a shortage. There are also concerns about tier two suppliers, which in this case are miners. Again, we don't think there is a concern as much about running out of lithium, but we do believe there is a concern, severe concern about price escalation in all of these. In fact, I was reading just this morning, the Bloomberg NEF has said that 2022, after 10 years of successive price reductions in batteries, there is an increase in 2022 in battery pack production cost. This is the first time since batteries got commercialized in electric vehicles that there is an increase. And all automakers have been basing their forecasts on the fact that batteries eventually will cost $100 per kilowatt hour or less to manufacture. Well, we reached 120, 125, and it's going back up. Why? Because, well, you saw the exponential growth curve that China has that is sucking up all the demand for both the tier two minerals as well as the batteries that are in production. So these demand supply shocks are going to keep happening across the next decade, right? Just today, again, in the morning news, coincidentally, Mary Barra, CEO of GM, has mentioned in post about EVs, but she is stressing how the supply chain is going to have to be resilient and adaptable. I think that jives very well with what we are also saying here, that yes, we can do all our estimates and we can match the demand and supply. It matches in a limited way, but overall looks like there is going to be a demand crunch or a supply crunch rather. But what is also required here is ability to navigate, respond rapidly, and move very in a very agile manner through all these changes. So what we think is going to be crucial to success is a cutting edge supply chain to complement cutting edge battery technology. I think the cutting edge supply chain is going to become as important, if not more. There has to be full visibility into all aspects of the extended supply chain down to tier 2 and tier 3 to detect these risks sooner. There has to be the agility to sense and respond very rapidly. And then there has to be very seamless collaboration across that extended supply chain, across the supplier partners, especially for legacy OEMs, because they have over the last few decades developed into an ecosystem where there are a lot of supplier partners. Today or over the next decade, all of those partners have to come together, work together in a very seamless, real-time manner to be able to compete with some of the new players who are more vertically integrated. So the industry does need, in our opinion, to invest in their next generation supply chain alongside investing in the EV technology itself. Because what we believe is the world's most complex supply chain, which is the automotive industry, over the next decade, with all of these permutations and combinations and variables, is also going to have to be the most agile throughout the next decade. I think that's probably the crux of the message we would want to give.
Yeah, Pranav, I think very well summarized. And I just want to go back for a second on the OEM piece, the legacy OEM piece. Right. So not only is all of this happening with regards to batteries and all of this change and all of this uncertainty and the need for that, very advanced, very nimble, very transparent supply chain. But they're also going through the ramp down of the internal combustion engine production at the same time. Their supply base, even setting aside batteries, their suppliers are having to change even what products and materials they will be supplying to their customers in the future. It is a top to bottom, seismic shift in the entire supply chain and in the auto industry. And I think, we focused on batteries today, but it's even larger, larger than that. So, the importance of that visibility, that flexibility, and the supply chain having the right tools in place, we think is really the way that those that come out ahead, 10 years from now, will have differentiated themselves as being able to quickly understand market changes, demand changes, supply changes, and react. Because nobody's going to be perfect at predicting this. So Pranav, should we go to some of the questions? I see one that came through relating to environment that I thought might circle back to something we talked about, which is the battery recycling.
Yeah. So do you want me to take that?
Yeah. Do you mind, Pranav?
Sure. That was a question from Paul on the how environmentally friendly is the mining of materials, given the colossal volume of batteries needed to replace fossil fueled energy, and it's a very valid concern. Lithium mining currently is very dirty, right? It is open pit mines, and it is a lot of damage to the immediate environment and the local ecosystem, in fact, in that region. Now, there are a couple of things I would say about this. I mean, not debating that it is dirty right now. The couple points I would like to make is, first, when we did compare the wheel to well emissions and the whole wheel to well environmental impact for oil and gas versus say the mining, right? So we found two differences, right? One is that we found overall, just to get the oil out of the ground, if we look at the mix of sources, yes, something like Saudi Arabia, where oil wells are already there for 30 years and all that, is less damaging. But if you look at the overall aggregate of oil, including shale and all those new areas which are actually similar to lithium, very damaging. Then just the mining of oil versus mining of lithium are those are the ones to compare. But the other part to that equation is lithium is required one time when you manufacture the EV. Oil is required every time you refuel your gas vehicle. So the total lifetime of a vehicle impact from lithium mining versus from oil extraction, even if we leave out the emissions, is still in the favor of EVs. Not to say that it is entirely clean, not by any means, but it is in the favor of EVs. The second part is battery recycling is actually a profitable business. So unlike plastic recycling, where it has to be government subsidized and all that, battery recycling, if you just think of China, the growth curve that I showed, right, that shows 6 million EVs sold in China this year. Now, if you think of that 6 million set of 6 million batteries is probably a better source of lithium than the mine next door, right? So, and there are many companies, Redwood Materials and so on, who are getting into the recycling business, as well as OEMs. And that recycling, because it is capitalism, that mining and the recycling is profitable, we do expect that to take off. So at some point in the future, the lithium demand will plateau, and from there it should be feasible to rein in the environmental impact, which is already better than oil. Just want to summarize that.
Thanks, Pranav. Hopefully that addressed the question. And something else I've been reading about is a lot of the battery manufacturers now are either partnering with third-party recyclers or building the capacity themselves and really designing the next phase of batteries to be a closed loop supply chain intentionally. So they're thinking about the full life cycle of the battery, as it being built in a way that can the materials can be more easily reclaimed at the end of the battery life. And so, the manufacturers are planning ahead for that as well. So it should become even a more and more profitable endeavor over time. And as those batteries, get into the market and eventually, in their life, they do actually have, quite long lifespans in the latest generation of batteries.
Yeah. There is another question, Bryan, on what is the scenario in India, I think from Swapnil. So the scenario in India is slightly different. I granted, for this discussion we focused our discussion on the US because because of the IRA, a kind of boxed in market that we can look at in isolation. But this whole scenario does expand to the globe also, in the sense that global demand, when you look at just cars, will probably be met. But when you look at the global demand, including grid storage and commercial vehicles, it is going to fall short somewhere between 2026 and 30. At least cause price escalations, if not at absolute disruptions to the supply chain. Now, India in particular, the total announced battery production capacity, even early plans in India, total up to around 21 gigawatt hours by 2030. Again, just read that a couple of days ago, not substantiated, but just came across that information. So 21 gigawatt hours is nowhere enough to power what India will need in 2030. So India is likely to become more of an import market for batteries. That does mean it is going to be tied to the global market, right? So it's not like just like US with the IRA, we can look at it in isolation. You cannot look at India in isolation. It is going to be an import dependent market for batteries unless there are a lot more announcements of battery manufacturing in the country. Looking at some other questions here.
Should we take this power grid one? I could take that one, Pranav.
Yeah, sure. Go ahead.
Yeah, so one of the questions that came in is, that even in the more conservative scenario, we're saying 50% of car sales by 2030 will be EVs, and wouldn't that result in a collapse of the power grid? Not to say there are not risks and strains, but it's not as clear cut picture as that. One of the main things to keep in mind is that the power grid is created for peak demand, and that peak demand is really 3 to 7 p.m. hot summer days, air conditioning on, be that in industrial spaces, office spaces, residential spaces. So outside of that window and those warm days, there is definitely sufficient capacity. So, this comes to the concept that a lot of EV charging will almost certainly be done at night when the overall demand on the power grid is much lower. And there are even concepts of using EVs as power repositories that could feed power back into the grid during times of very, very high demand. So that's one aspect of it. As long as everybody's not trying to charge from 3 to 7 on a hot summer day, for the most part, there's a lot of excess capacity within the grid. Second of all, even though we're saying it's 50% of the vehicles by 2030, the new vehicles sold, it's maybe not quite as big a number as that sounds, because there are 250 million passenger cars on the road already today in the US. So even with that growth curve of 50% of new car sales by 2030, that would still be less than 20% of the total cars on the road. So it's still most of the cars on the road would still be internal combustion. And so it's even though it is a very big number of EVs, and that will require considerations for the grid, because we're talking new car sales, even with those high percentages, they do kind of trickle into the base of actual usage over time.
Yeah, and I think the one thing I keep saying is that even California has mandated like 2035 no more gas car sales, right? But that doesn't mean 2035 all cars on the road will be electric. That just means an average car lasts 15 years. So if you ban car sales, ICE car sales in 2035, you're looking at the entire vehicle population being electric somewhere between 2050 and 2055. That is a lot of time to make upgrades to a power grid. It does require political will, does require investments, but those are in a way profitable investments, I would say, as we move away from oil volatility affecting the economy and so on. So I think that it is, we have to look at it in that perspective, 2050, 55, not looking at 2035 as when the grid will collapse. So yeah.
Very good point.
So I think one other question was interesting was, aren't there other factors like in the demand supply equation which we calculated? Aren't there other factors which will play in, like availability of charging infrastructure and so on? Very valid point. Those factors will play in. But I think what what we've seen in markets like Norway, where it's 80% plus electric, and China, where it is now 20% plus electric. I mean, for once, the US is in a position of being a follower, so we have the advantage of being able to look at what happened in the leader markets as far as EV adoption is concerned. So what has happened there is all these concerns. I would say the concerns are in two buckets, right? One is a perception bucket, and the other is an actual physical constraint bucket. So the perception constraints do tend to go away when 5-6% of the population adopts any new technology, which is now the case in the US. So we would expect now some of the perceptions going away because of everyone at least knowing somebody who owns an EV, first person, right? And they can get first-hand information. So charging infrastructure is one like that, right? If we think if there is a physical constraint for certain people in rural areas who have traveled long distances, or there is a constraint for people who are on the road practically all day. But for the vast majority of the population, it is more of a perception, because people are used to gas vehicles. They compare gas vehicles, the fuel stations, to charging stations, and they say, oh, it takes 10 times longer to charge and there are fewer charging stations. It doesn't work that way. When you actually own an EV, you realize, well, 90%, 95% of the charging happens at home, right? So for the 1 or 2 or 3 road trips a year that people take, it is a minor inconvenience to have to wait at a charging station. And for that, the US highways are already covered with charging stations. So you won't run out. You just have to wait for 30 minutes or so to get your car charged up. So that makes the whole problem seem much smaller. So I would say this is a bigger perception issue than an actual issue. And that's I think what is starting to happen. People are starting to realize that happen. Like, in fact, now people ask, the EV owners are asking the gas car owners, what, you have to actually go somewhere to refuel? That's weird. That's very inconvenient, right? That's the kind of statements that will catch attention and make people realize, hey, it's not the whole equation that they were looking at before. I think a similar perception issue is battery replacement costs. I think because of mobile phones and because of even the first generation of EVs, which had a lot of battery degradation, people look at their phone and say, well, the battery dies in 3 years. So maybe for my EV, the battery is going to die in 3 years. And well, the battery is half the cost of the car. So you're going to have to shell out $20,000 or something every 3 years. That's, again, that's mostly perception. It was mostly perception in 2015. As of today, it is completely perception, right? So it is, today batteries are developed to outlast the car, at least the 200,000, which is the average gas car's lifetime. Batteries are very well positioned to outlast that. Actual user data is showing that. But that perception has to still sink into reality. And once people realize that, then I think then the innovation innovation curve starts going exponential. So that's, I think, what we will see. There will remain physical constraints, like I mentioned, long travelers, also people in apartments and others who don't have access to charging at home. That is a severe constraint which will remain potentially. But yes, the growth can be exponential once the constraints, which are perceptions, go away.
Pranav, just to the apartments in dense urban areas question, as you know, I live in New York City, and it's kind of one of the interesting developments. The city has started reserving street parking locations specifically for EVs and providing charging stations. So not only is everybody wants to find a parking spot on the street around here, so that gives you preferential treatment. It also helps with that concern about being able to charge. And when I first saw those, they were often empty. Now I've seen people waiting for them as I think we see the EV market obviously accelerating. And so, there's a lot of solutions that both, I think the commercial world and the, government side of things will continue to work to solve. And as you were pointing out, none of those perceived constraints seem to actually be, long-term limiting. And I think it's a very, very bright future, obviously, for the EVs.
Thanks, Bryan. Yeah, that's good news. I think one more question from Swapnil. I think, are the statistics for demand and supply, considering that other conventional and unconventional sources of engines in coming time. Right. So the way I'd answer that is it does consider conventional engines, which is mainly internal combustion engines. So those are factored in with all variations, including the gas, diesel, biodiesel, and rotary engines and the variants thereof. All right. So it does consider that. I think we've seen this growth curve and the predictions apply equally to cars and to even two-wheelers. Like in a market like India, which is dominated by two-wheelers, again the number of OEMs who have come out with products which are electric is staggering. So that does tie out. As far as unconventional sources of engines or energy are concerned, the main competition that electric cars were facing was from fuel cells, which require a hydrogen infrastructure. So if you think of when Tesla launched their first EV or when Nissan launched their first EV, 2011, right? We are a decade in, and we are still talking about how charging infrastructure, very easy to set up, is still not in place. So if we think about hydrogen, fuel cell based vehicles, Toyota has had those for decades again, but the infrastructure has still not even started to develop, and it is very expensive, $40 million for a single hydrogen pump kind of cost. So that is not something which will become universal by 2030, the forecast horizon that we are looking at. It could become very applicable in like the cat example that Bryan mentioned, right? It's in a geofenced area which is used for mining. They could set up one hydrogen power plant and replace the battery use by just going hydrogen fuel cell. So that's where we said those could have niche applications which could reduce demand, but they're not going to cut a big dent into the demand for EVs. I think those are now, going up regardless of other technologies coming in, at least till 2030. Looking to see if there are any other questions. Yeah, I think that's what I'm seeing here. So
I think, and I think we're about at time, Pranav. I think Priyanka, do you want to close this?
Absolutely. Well, thank you, Bryan and Pranav, both. I mean, you unpacked a lot about EV batteries in just a small amount of time. And it was very educational, at least for me. I mean, I learned so much I didn't know before in terms of surveys, in terms of what kind of conversations are happening behind the curtains, and no, not everybody's privy of that, and where the future looks like. Lot of key takeaways for me. There were two that are essential. Like if looking at one was from Pranav, like looking at US from reaching to the 50% mark in 2030 for the EV batteries, we are rather closer to the mark in the sense we can reach there by 2027 or 2026 that Pranav said, because we're already on an exponential curve. However, to reach there, we must also be prepared to have the 6,000 gigawatt hours capacity into production already. We cannot just wait for it to go into production. We should be already into it if we want to reach the demand and supply and getting into the implementation. Otherwise, we will be very far off the line. And the second thing, Bryan, was from you. I remember you said to, sourcing material in US, looking at the IRA policies and sourcing it at a cheaper cost. These are the two things that one has to look for reaching the demand and supply equilibrium, and that's how it should look in the future. So these were the two key takeaways for me. Outside of that, I'm sure there are a lot of key takeaways. A lot of people reach out to us. Unfortunately, due to paucity of time, we cannot address all the questions right now. But in case anyone have more questions, they can reach out to us. They can reach out to Bryan and Pranav Padgaonkar, and I'm sure they both will be very thrilled to answer all the questions required. And there will be more sessions coming up. For more information, there is stay with us on our channel. Till then, have a great day ahead, and thank you both again for doing this.
Thank you.
Thank you, Priyanka. Thank you, Pranav. Thank you, everyone who joined us. Appreciate it.